Now let's talk about this broadcasting, which I was saying that what we have a different matrix size, right? Shape of the matrix are different than how it is going to work, right? Sorry. Sorry. Now let's print these zeros. So give me a second. This zero, we already know what is zeros, right? NP dot zeros, 3 rows, 3 columns. This has been already discussed. Fine, it's a straightforward. Now create one more Numpy array. This is one more Numpy array. So here what we have? Here we have a 3 cross 3 and here 1 cross 3, right? So size is different, shape is different, right? So now let's try to do some operation between this and this. So here I'm saying start is what? This guy plus add underscore rows, which this guy. So 102, okay, let me write it properly. 102 and we have 0, 0, 0, 0, 0, 0. This is how we have. And I'm trying to add it. This is what it shows here. So how it is going to work? So the idea is very, very simple. This is the very first or the 0th index, right? Column wise. So all the 0th index elements, right? So this will be added to this. So 1 plus 0, 1, 1 plus 0, 1, 1 plus 0, 1. Straightforward. Then this is the first index. So it will be added to the first index only. 0 plus 0, 0 plus 0, 0 plus 0. Similarly, this is the second index. And here also it will pick the second index. 2 plus 0, 2 plus 0, 2 plus 0. So this will not be added to any other columns. The respective positions only it will add. Right? Pretty straightforward. Even nobody explains you, so it is very easy to interpret this. Right? Now let's try a different way. So I will take this add rows. What is that? This 102. And here I am saying a dot T. Dot T. What is this dot T? It is basically transpose. Sorry. Transpose. What does it do? It will convert your data this into this. It will just convert your horizontal data into vertical or rows into columns. You know, say 102, so it will change it to 102. Right? So let's print that. We had 102 here. The same thing I converted into vertically. So that is basically what? Transpose. One row converted into multiple rows. Right? That is a dot T. So what I'm going to do, I'm going to, this 102, I'm going to say plus again your start, which is 0, 0, 0, 0, 0, 0, 0. That is what the start, right? So let's execute that. So now you can see the first row, right? So this is not 1, 0. So basically, let me write this 0, 0, 0, 0, 0, 0, 0. This is basically what start. So this is the calculation we are trying to do. So this is the first row. I mean the 0th index row. So here it will be pick the 0th index. 1 plus 0, 1 plus 0, 1 plus 0. Then the second row, 0 plus 0, 0 plus 0, 0 plus. This is the third row. 2 plus 0, 2 plus 0, 2 plus 0. Right? Now let's try it forward. So if it is one row, then it is, we have seen how it is going to apply. If we have multiple rows, we have seen how it is going to interpret and do the addition. Right? Matrix multiplication, matrix addition, whatever you want to achieve, you can achieve in the Numpy. Everything can be done. Now, let's, what is this? So here we are just trying to transpose it. So we already discussed this, right? 0, 1, 2, 3. So we have transposed here, taken this data, and I said a dot tree. So I'm just printing that. So it is horizontal data converted into vertical. Right? That is about transpose. Now let's look into the array math. Last part of the Numpy. So I am generating random integers in math 1. Again, I'm generating random integers in math 2. All are, both are in the same shape, 3 cross 3. I'm just trying to print here. Let's print this. We can see that everything is same, right? Everything is same in the math 1 and math 2, but still our numbers are different because of the randomness, right? Because of the randomness. So now what I'm going to do, I have just printed here. So this is math 1 and math 2. Now, if I want the square root of these guys, square root of each and every element in the math 1. So yes, we have functions numpy dot square root, np dot square root. So your matrix name. So each and every element will be taken the square root of that element and will be put it in a new matrix. Right? So let's do that one. So this is the square root of this matrix. Every element, this element square root, this one, this one. So the result will be displayed in this new matrix. Similarly, 4, 3, 2, respective position, you can find the result of that square root. Similarly, if you want to square it, yes, you can square it. Here I have taken mat 1. You can take mat 2, whatever the matrix you want to convert into different size, different numbers based on the functions we have. So I'm using a numpy dot square, numpy dot square, right? So it will be squared each and every element and will be placed in the same position. 7, 7, right? Square of 7, square of, this is matrix 2. So I'm talking about mat 1 here, right? Give me a second. Okay, so here you can see square of that matrix. And obvious question is that how many functions we have? We have seen this in the earlier sessions, I think starting, I would say. So how do I know that what are all the functions we have in the Numpy? So what you can do, you can say dir Numpy. But before that, you have to import, okay? So import the Numpy and say dir Numpy. So it will give you all the functions that are available in the Numpy. There are a lot many. We don't use all of them. Hardly we use maybe around 10, 15. Okay. So with that, we have completed the Numpy.